In this video, we shall be looking at all the questions that are related to dot or scalar product and all the available questions that are related to cross or vector product. If we are finding dot product, our final answer will be a scalar. That is, it will be a numerical value like 5, 1, 2, 3, 7, 8, 9, 10. It will be a numerical value. If we are finding a cross product or a vector product, our final answer will be a vector. You know, when we find a cross product of two vectors, the final answer we'll be getting will be a vector. When we find a dot product of two vectors, the final answer we get will be a scalar. So let's look at some of the features and what we can be able to get or use with this. These are questions that we can solve under when we have two vectors and we want to find either their dot product. The first question is to find the dot product, that is A dot B. And I want us to understand that when we have a letter written in bold letter, it shows that it is a vector. We can equally probably have the vector in such a way that we can have a line under it. If I have a letter and I have a line under it, it shows it is a vector. Or if I have the same letter and I have arrow over it, it shows that it is a vector. But in print, we can use bold letter. So it's either you use a letter that has a dash under it, or you use another one that has arrow over it. So we can find A dot B. It will give us a scalar product. These are the questions we'll be looking at. We can find the magnitude of A itself or the magnitude of B. We can find the angle between A and B. Then when do we use A dot B is equal to AB cos theta? Then what is the direction cosine of a vector? Maybe vector A, vector B, vector C, a vector that has been given. Then what is the magnitude of, maybe you are multiplying a vector with a numerical value, or you are subtracting a vector from a vector. Then what is the cross product of a vector? The cross product will give us a vector product. Cross product will give us a vector product. Like A cross B, our final answer will be a vector. But A dot B, our final answer will be a scalar. Then we have to show that vector A or vector B is orthogonal or perpendicular or is at 90 degrees to vector to their cross product. So if I have vector A and I have vector B, the cross product will be perpendicular to the plane, to this plane. You know, if I can to this plane now, this is their cross product. This is their cross product, which is vector C. It is perpendicular to this plane, to their plane. It will be perpendicular to the plane of, let's assume that this is my A, this is my B. So this is C, which is their cross product. It is perpendicular to the plane of A and B. So it will be at 90 degrees to B and it will be at 90 degrees to A. And that will show us that our answer is correct. Then what is I cross J and J cross I? Are they the same? How do we get them at the tips of our finger. Then what is 2j cross 4i? Then when can we use a cross b is equal to ab sinθ? We know that a cross b itself will give us a vector. Then when can we use ab sinθ? We can use it when we want to find the magnitude of the vector that we have been able to get. The vector of a cross b, the magnitude of a cross b will be equals to c. So what's the magnitude of c? So let's assume that we have these two vectors. Let's assume that we have these two vectors, and these two vectors we have 2i plus 3j minus 5k. It can be any form of, it can be any type of vector. Let's assume that we have b to be 4i plus 2j plus 3k. In having this, what we have now, we can easily work with it. You can easily work. What we are simply saying is that I have, this is in 3-dimensional. I have my vector in 3-dimensional plane. Then this is my y-axis. This is my x-axis. This is my z-axis. Then we have a unit vector in this direction. This is j. We put a cap on it. This is I. We put a cap on it. This is k. We put a cap on it to show that it is a unit vector. So in the direction of I, which is x-axis, so if you measure from the origin to this point, so we have it to be 2. So it will now be 2i. 2i in this direction. Then this will be 3j in this direction. That's in the y-axis. And this will be 5k. That will be 5k in that direction. Then recall that a dot b is equal to I cosθ. That is the magnitude of I times the magnitude of I, then cos the angle between I. And in this case, if you are looking at I, the magnitude of I is 1 because it is a unit vector. The magnitude of I is 1. It is a unit vector. So if I find the magnitude of a unit vector, it will give me 1. And if you look at the angle between them, the angle between them is 0 because they are on the same line. So 1 times 1 then cos 0 will give me 1. So the answer is therefore 1. So I dot I is equal to j dot j is equal to k dot k, and it will give me 1. And also I dot j will equals to the unit vector I times the unit vector k. That's the magnitude now. Cos 90 degree. The angle between j and I, this angle is 90 degree. The angle between k and I is 90 degree. The angle between j and k is 90 degree. So we have it to be I. So we have it to be I dot j is the same thing as I dot k, is the same thing as j dot k, is the same thing as j dot I, on and on like that, and it will give us 0. Because we need these two relations when we want to find our dot product. So the question now says, what is A dot B? It is simply putting vector A at this point multiply by vector b. Multiply by vector b. So if we look at this relation, I can say 2i times 4i, and we have 8i squared, or 8i dot I. And don't forget that I dot I is equal to 1. So I will have this one to be 8. So 2i dot 2j, because we know that I dot j is equal to 0, so that will be 0. There's no point in writing that. 2i dot 3k, we know that I dot k is equal to 0. There's no point in writing that. We move to this one. 3j times 4i, we know that I dot j is equal to 0. So there's no point in writing that. 3j dot 2j will give us 6j dot j. Since we know that j dot j is equal to 1, so that will give me 6. Similarly, we do for this. So we only do minus 5k times plus 3k. That will give us 15k dot k, which will give us minus 15. So 8 plus 6, then minus 1. That will give us 14 minus 15. So for this very expression, for this very question, our a dot b is equal to minus 1, which is a scalar product. Our dot product, we are not finding the magnitude now. Our final answer in this case is minus 1. But if we are to find the magnitude of a vector, then it will always be a positive value. Then the next question is, what is the magnitude of A or B? So the magnitude of a vector will be that vector. It will be the scalar product of that vector. So if I take my B to be B dot B, if I take my scalar to be B dot B, if I take my scalar to be B dot B, which is equal to BB cos theta, you know, this will give us magnitude cos the angle between them. What is the angle between B and B? It will be 0. So I can now say B square is equal to B dot B. So B square is equal to B dot B. So this is my first B. So if this is my first B, so this is my first B, which is a vector, times the second B, or dot the second B, which is also a vector. Like what we did just now, it will now be 4 times 4, because I dot I will be 1, 2 times 2, it will be 4, and then 3 times 3, it will be 3k dot k, and k dot k is equal to 1. So it will now be 16 plus 4 plus 9. So it will be B square is equal to 16 plus 4 plus 9. So we will now say B is equal to square root of 29, which is equal to 5.38. So with that, we can say that we can get the value of our scalar product. With that, we know that the value of our the magnitude of B will give us a scalar product. And similarly, we can do that for A. A will be 2 times 2 plus 3 times 3 plus minus 5 times minus 5. Then we find the square root. That's what will give us the magnitude of A. Then, what is the angle between A and B? And when do we use A dot B is equal to AB cos theta? So we use what we have in question 4. We are to find the angle between vector A and B. What we have in vector 4, what we have in question 4, it is a use when we want to find angle between A and B. And we look at this, we can easily find what is our A dot B divided by AB will give us cosθ. Then if we find the inverse of this cos, it will now give us cos inverse A dot B over the magnitude of A times the magnitude of B. In the last solution that we have, we know that A dot B is equal to 1. And the magnitude of vector B itself in the last solution we did is 5.38. The only thing we need to find now is the magnitude of A, and then we put it into our equation to get our answer. And to find the magnitude of A, it will be A squared is equal to 2I plus 3j minus 5k into 2I plus 3j minus 5k. So we simply say 2 times 2, which will give us 4, because we have I dot I, which will be 1. And if you multiply 2 by 3j, 0, 2I minus 5 times minus 5k, that will be 0, because I dot j will be 0. Then 3j times 3j will give us 9, j dot j will be 1. Then minus 5 times minus 5 will give us plus 25. So we have it to be 38. So A squared is equal to root 38. So the square root of 38 will give us 6.16. Then we can input that into our equation. So if you look at our equation very well, it will now be minus 1 divided by 6.16, then times 5.8. Then we find the cos inverse. So our answer is 1 divided by 33.16, and cos inverse will be minus 0.030153. If you press your calculator, I will find the cos inverse. It will give us 91.73 degree. So we have 91.73 degree. And then with this, it's telling us that vector A could be like this and vector B could be like this. So the angle between them is like this. But since it is 91 degree, we know that 90 degree, so it will be in this form. We have it in this form, a little bit bigger than 90 degree. So this is the angle between them. So this will be 91.73 degree. So this is vector A. This is vector B. And the magnitude we were finding is this will be, if this is vector A now, and this is vector B. So the magnitude will be the length of this vector. That will be our magnitude. Then what is the direction cosine of a vector, either vector A or vector B? What you need to do in that case is to find the magnitude. You find the magnitude of the vector and you divide it by each. You divide the vector by 8. So we will have it to be the magnitude of A is root 38. The magnitude of B is root 29. So 2I divided by root 38, 3j divided by root 38. You know, we have A vector A equals to 2I divided by root 38 plus 3 j divided by root 38, then plus this one's supposed to be minus. This one's supposed to be minus. So minus 5 over root 38. So the direction cosine for A, the direction cosine for A will be the coefficient of I. This is the coefficient of I, coefficient of J, and coefficient of K. So for A now, the direction cosine will be 2 divided by root 38, 3 divided by root 38, minus 5 divided by root 38. And similarly, direction cosine for B will be 4 divided by root 29, 2 divided by root 29, 3 divided by root 29. Then what is the magnitude of 2b and the magnitude of 3b minus 4b? We simply put it as 2 into vector b. This is vector b. We multiply 2 with vector b, and it will be 8i plus 4j plus 6k. So this one is equal to 2b. B is a vector. We are only increasing that vector b by a value of 2. Then what is 3b minus 4a? 3 into 2b, vector 2b, then minus 4 into vector a. After you have done that, then you collect like terms. 2i minus 8i will give us 4i. 6j minus 12j will give us minus 6j. 9k plus 20k will give us 29k. So we can be asked to find the magnitude itself. What we have found now is 2b and 3b minus 4a. You can do that as an exercise. For us to find the magnitude of 2b now, we have been able to find 2b, we have been able to find 3b minus 4a. The magnitude of 2b will now be 2b squared will now be equals to, you multiply this, so it will be 8i times 8i. If we do 8i times 8i, it will be, if you do 8i times 8i, that will be 8 times 8, that will give us 64. That will give us 64. Then plus 4j times 4j, that will give us 16. Then 6k times 6k, that will give us 36. Which is equals to 64 plus 16 plus 36. That will give us 116. 116. So the magnitude of 2b the magnitude of 2b will be equals to the square root of 116. And similarly, we can find the magnitude. So you just say 4 times 4 plus minus 6 times minus 6, then plus 29 times 29, and you find the square root. That will be the magnitude of 2b, 3b minus 4a. Question 7. The same vector that we have is a 2i plus a 3j minus 5k, then 4i plus a 2j, then plus a 3k. So we can easily find the cross product, and the cross product or the vector product, we need to work with ijk before finding this. We know if ijk are unit vector in the direction of x, y, and z, note the cross product of two vectors, we have the result to be perpendicular or orthogonal to the plane of the two vectors. This is what we are simply saying. If I have a vector like this, I have another vector like this. This is y-axis. This is x-axis. We have a unit vector I in this direction. We have a unit vector j in this direction. We have a unit vector j in this direction. So if I have it in this way, the product, if I'm doing I cross j, my answer will be perpendicular to the plane of I. This is the plane of I, this plane. This place, the whole of this place is the plane of I cross j. Their product will be perpendicular to this plane. So this will be z axis, and we have k in this point. So I cross j is equal to k, j cross I is equal to I, k cross I is equal to j, j cross I. If I'm going anti-clockwise, my answer will be positive. This will be equals to k. If I'm going clockwise, if I now have j cross I, j cross I, my answer will be minus k. Minus k. If I do j cross I, my answer will be something in this negative side. So if you are going anti-clockwise, your answer will be positive. If you are going clockwise, your answer will be negative. So if I say j cross I, that's clockwise, that will be minus k. K cross j, that's still clockwise. J cross k is still clockwise, minus I. Then I cross k, that's still clockwise. I cross k, that will be minus j. But if I'm going anti-clockwise, I cross j will be k, then j cross k will be I, then k cross I will be j. And we can see it in this format as well. Anti-clockwise movement will be positive, that is I cross j is equal to k. Then clockwise movement will be negative, that is j cross I is equal to minus k, which we can look at this place and we can see the movement as well. You know, if you move clockwise in this way, it will be that, and if you move in the other direction, then it will give us that. So what is I cross J and J cross I? That is what we just solved now. So I cross J, because we are moving in the clockwise, in anti-clockwise direction, our answer will be K. When we look at J, if we look at J cross I, because we are moving in the clockwise direction, then our answer will be negative. If you move in the clockwise direction, your answer will be negative. You move in the anti-clockwise direction, your answer will be positive. So it can be established that A cross B is equal to minus B cross A. But A cross B is not equal to B cross A. However, A dot B is equal to B dot A, since the two will be equal to product of a scalar product and cosθ, and the cosθ will be the angle between them, which will be the same. Then for question 10, you can find what is 2J cross 4I. The first thing you need to look at is J cross I, is it clockwise or anti-clockwise? So since J cross I is clockwise, so we have minus K. 2 times 4 is A. You can easily solve that question. Then the cross product of two vectors, that is A cross B. Note that B cross A is not equal to A cross B. The first thing you have to do is you write it out in matrix form. You write this one out in matrix form, and when we do that, it will be, we will write I in this matrix form, I minus J, then K. Then we have 2, 3 minus 5. This is 2 under I. This is 3 under J. This is minus 5 under K. Then 4 under I, 2 under J for B, then 3 under K. To do the operation on this one, we start with I first. So we cross this and we cross this. Because we are crossing it for I, then we are going to take the remaining we are going to take the remaining value, which is I now will be the matrices of I. So this is for I now. Then we move to J. To do J, we will cross where we have J. We are left with 2 and minus 5, 4 and 3. Then you will write the minus J outside the matrix. Minus J after the matrix. Then we move to K. We move to K. To do for K, we cross where we have K. So we write K outside, then we take 2 and 3, 4 and 2. Then we put the K outside. After that has been done, then we now do the operation on the matrix. So it should now be 3 times 3, then minus 5 times minus 2 times minus 5. You take the operation in this form. we do the operation in this form. So we have I into 9 minus into 2. You need to put bracket here so that you don't make mistake when you want to open the bracket. Then you do 6, that's 2 times 3 will give us 6. Then minus into 4 times minus 5. Then plus k into 4. Because there's no minus in this case, you can just put a minus straight away. 4 into minus 4 times 3. Then our final answer will be 9i minus 26j, then minus 8k. So this is the vector product of A cross B, and our answer is another vector, which is vector C. Then show that A or B is orthogonal or perpendicular to the cross product of A and B. Let A cross B is equal to C. That is, let the answer be C. This will be perpendicular to the plane of A and B. We have explained this. If it is the dot product of C with A or B, if we find the dot product of A with C or C with B, if that dot product is equal to 0, it means that our answer is perpendicular to the plane of A and B. Because when we find a dot product that is A dot C, will give us AC cosθ. It means the angle between them is 9. We can have A like this, B like this. This is the plane now. This is the plane of A and B. This is the plane of A and B. So our vector C at this point is perpendicular to this and is perpendicular to this other one. That is perpendicular to the plane. So finding the dot product with the value of C that we have been able to get with the value of A, our answer is 0. Since A dot B is equal to CB cosθ, if theta is 90 degrees, cos 90 degrees will be 0. The whole equation is 0. So vector C is at right angle to the plane of vector A and B. So it means that since we have been able to get 0, it means our vector C is orthogonal or is perpendicular or is at 90 degrees to the plane of A and B, or to the cross product of A cross B. So for question 11 now, we want to look at when is this useful. A cross B equals to AB sin theta. If we find AB sin theta, it will be a scalar product. If we find AB sin theta, it will give us a scalar product. Or we want to find the magnitude of C. We can find the magnitude of C, vector C itself, because A cross B is equal to vector C. So I can find the magnitude of C itself. As we have done before, to find the magnitude of C will be C multiplied by itself. So we can simply find it like 19 times 19, because it will be I square, then minus 26 times minus 26, then minus 8 times minus 8. Then our answer will be 1101. We'll find the square root, we have 33.18. Let's look at the second option. Our second option is we want to use AB. A dot B is equal to AB cosθ. The first thing we have to do before we can do this is to find the angle between them. So in finding the angle between vector A and B, we will go back to the dot product. If we get to the dot product, we are going to get what is theta. This we have done before. We don't need to go over this again. Just do A dot B over AB. Then our answer is 91.7 degrees. In getting this, then I can now come back to A cross B is equal to AB sin theta. What is my A? 6.16. What is my B? 5.38. Then sine theta. We have been able to find this theta from A dot B. Then if we evaluate this, we will see that our answer is 33.18, which is approximately equals to what we have as a 33.18. It's approximately equals to if there's no approximation in the calculation, it will be exactly the same. Then these are the questions that you have been able to look at. What is A dot B? What is the magnitude of A or B? What is the angle between A and B? When to use A dot B is equal to AB cos theta? What is the direction cosine of a vector? What is the magnitude of 2B and the magnitude of 3b minus 4b? You need to find 2b itself first. You need to find 3b minus 4a first before you can find the magnitude. Then a cross b, the vector product, show that a or b is orthogonal. We'll find the dot product of our a cross b with the answer that we have gotten. Then what is I cross j? I cross j, we are going anti-clockwise, it will be positive. J cross I, we are going clockwise, it will be negative. So I cross j will be k, and j cross I will be minus k. Then what is 2j plus 4i? What do you do in that case? You look that j cross I, is it anti-clockwise or clockwise? J cross y cross I is clockwise, so it will be minus k. 2 times 4 is 8. Easily we are done with that. Then a cross b, when do we use a cross b is equal to ab sin theta? When we want to find the magnitude of a cross b, you can find the magnitude of a cross b. Thank you for your time, and thank you for the attention.
Thank you, and God bless. We appreciate your comments, your feedback as we grow this channel together. Please like, share, and subscribe to this channel for more updates, for more information. Thank you for your time.